Good afternoon, everybody. Thank you for joining us. Today we have a webinar called Curtain Greenhouse Systems, and we have two people on the panel today, Scott Thompson and Paul Golden, both with Prospient. Scott has, as he just mentioned, 33 days left before he retires, so this is his last hurrah. Sorry, Scott, I had to throw that in there. My name is Tara Willsworth. I handle marketing here at Prospient. If anybody on the call does have questions, please use the chat to put them in. If they're relevant at the time, I will ask the question. If not, we'll just wait till the end to answer all questions. I also have some email addresses that you can, if you don't want to ask during the webinar, you can follow up afterwards. With that, I'm going to move on to introductions. So Scott, introduce yourself and tell everybody a little about yourself.
Thank you and welcome, everyone. Appreciate you being with us today. I'm Scott Thompson. I'm a 45-year industry veteran, and I'm hoping today that we can share with you what I've learned and seen regarding the basics of curtain systems in multiple decades of experience that have been used for shade, heat retention, and light deprivation. I have a Bachelor of Science degree from Monmouth University. I'm a past president and board member of the National Greenhouse Manufacturers Association and currently with Prospient. Paul?
Thank you, Scott. I'm Paul Golden. I've been in the greenhouse industry for the last 20 years, both as a manager, designer, and ultimately a salesman in the industry. I'm the director of sales for Prospient's commercial division, so we focus on ornamentals, primarily nursery crops in my division. I have a BS in applied physics from Bowling Green State University in Ohio and a master's in engineering from Stanford University.
All right.
Thanks, Tara.
Let's get into curtains.
Prospient is currently the largest North American greenhouse manufacturer in the industry with facilities both in Canada and Cincinnati, Ohio. We offer the widest variety of greenhouse styles and applications of any company that's in the industry. One of those product offerings is curtain systems. Our intent today is to basically share the basics for both shade, heat retention, and light deprivation. Paul, any other comments?
So just our agenda today we're gonna touch on all those subjects Scott just mentioned, all the different types of, the generalities of curtain systems, the different types of curtain systems. Then we're gonna dive a little deeper beyond the basics. We're gonna talk about common issues we see with curtain systems and solutions that are out there in the industry that we've found or worked with partners on. We're gonna give everyone a chance to ask questions too. We're gonna discuss all the different types of fabrics that get used, and then the practical challenges of different types of systems, and then we'll talk a little bit about what's next for the industry.
This is a video, so I'll start playing it, but it doesn't have any sound, so if you want to talk over it, that's fine. Isn't the right thing?
So in this video here, it's kind of a sped up version. These curtain systems don't move this fast in real life, but what you see here is a flat slope style curtain system that's mounted to the truss, and it travels from truss to truss using a push tube drive system. That's a rack and pinion system, which is what's mounted to the leading edge, and then it's guided by a bed of wires. Usually has a bed of wires above it and below it, and so you can see here it's kind of moving along the length of the greenhouse, again from truss to truss. And here's just kind of different angles of what that looks like. So what we're talking about, this is kind of just to bring everyone's mind around what we're talking about today. We're talking about internal shade systems primarily, and these are automated shade systems. So this is all computer-driven, motor-driven shade.
How fast does it really go? I mean, I know they've speeded up, but you can see it move, right?
In real life, it takes closer to about a minute to go from one truss to another. This is a nice diagram where it shows how it moves inside the structure. This is an A-frame style structure, so it's following the flat slope profile. So it follows the roof slope, and then it goes horizontal for a second, then it goes back down the other roof slope. So we'll talk about this in the next slide a little bit, but I just want to give everyone a little bit of a visual representation of what we are talking about, because it's kind of tough just to look at pictures. Go ahead, Scott.
Yeah, so what we were just showing there, what Paul showed, were a single system, slope, flat slope, rack and pinion driven, and primarily used for shade, to shade your crops and reduce the solar gain inside the building. And then it also applies as a heat retention. So you can change the fabrics. The heavier the shade, normally the heavier and the better the heat retention. When I say heavier, meaning less light penetration. There's a variety of different systems. Like we have here, we have listed both heat retention and energy curtain, which you just seen, just the shade, and then also shade, blackout, and light deprivation. If you look to your right, that photograph shows 2 layers of curtain systems. The upper is a light deprivation, and the lower is a shade system. So you have solar gain, and then you also have solar gain control underneath. And then on top, you have a light deprivation system that is used to help regulate the light completely inside greenhouses. It's been much bigger and used recently for cannabis production, but it originally started in the late 50s and early 60s with potted mum production. And what was found is that if you altered the amount of light on the crop during certain parts of its growth cycle, that you could improve on the production of budding and control how things flowered and get on a more attractive and efficient schedule. And that kind of research was developed in the late 50s and early 60s. Paul?
Is that how they use? Do they use the blackout curtain for poinsettias as well?
They can.
Poinsettias,
yep,
poinsettias, chrysanthemums, any crop that you want to change, manipulate the photo period and force it into budding outside of its normal, fall, early winter stages that it would normally bud. And then the other thing that we see a lot of blackout being used for these days is light abatement. So they might not have a crop underneath there that needs the ability to maintain photo period. They actually may be running their lights while the curtains close. And the idea here is that you're just trying to be a good neighbor to a lot of the surrounding environment. So you'll see light abatement curtains being used a lot up in Canada for produce production, where you have multi-acre, tens and hundreds of acres of lit vine crops. So they try to prevent the light from leaking out of the greenhouse into the surrounding environment. You also see it in a lot of affluent communities too, where you'll see local production being done for small produce, or even sometimes flowers, just trying to prevent the light from bothering the neighbors. So kind of getting into the different types of drive systems. So most of what we showed you so far, and what's shown on the right-hand side here in the photo, these are push tube type of drives, and they tend to go truss to truss, as we mentioned in that video previously. The other type that's very common, probably even more common around the world, is the spool and cable, or the cable and drum drive system, which kind of works a little bit like a wire that's pushing or pulling the lead edge of the curtain system as it wraps around a spool. And those can go either gutter to gutter or truss to truss. They always tend to be flat for the most part, because of the way that they're designed. And the contrast to those versus the push tube system, you can have sloped push tubes, you can have flat push tubes, or meaning the curtain itself is flat, or the curtain goes up the rake of the roof, might go all the way to the peak. That's a slope system, or it goes sloped up part of the roof, flat for a section in the middle of the roof, and then slopes back down the other rake. And the way that people use their curtain systems for ventilation has a big impact on what type of drive system they want to use. A gutter to gutter system, you may crack your curtain to let heat out of the greenhouse through the roof vents. And if you do a gutter-to-gutter system, you have one large crack along the gutter. Let's just say it's a foot wide times the length of the greenhouse, which is good. But you might have a wide house too. You might have a 30 or 40 foot wide house, so it's not as much space as you would get as if you were to crack each system at a truss to truss on a truss to truss push tube system, where you have now maybe a foot every truss, which are typically spaced every 10, 12, or 14 feet, give or take. So you get more ventilation through a greenhouse with a truss to truss system, or a system that goes from gutter to gutter and has multiple little peaks, and there's a crack at every peak. So it's all about how you're using your greenhouse. If you're in a passively ventilated greenhouse, you have to think about whether you need to crack that curtain system during the daytime to allow heat out. And we'll also talk a little bit about the type of fabrics that could be used. I'm going to let Scott talk about that allow air to pass through the fabrics, or they act as a barrier to prevent penetration from below the curtain to above the curtain.
And to Paul's point, it's a terrific tool. Increased gutter height within your structure allows you to do a lot of different things with how you're going to lay out your curtain. You want to have nice separation between where your crop and your curtain is for the most part, and also where you suspend it. It allows you to put additional items, like you can see in the photograph, where there is lighting underneath the curtain. There's circulating fans underneath the curtain. There's a suspended CO2 generator. So all of those items, as well as if you had overhead watering booms, anything like that, you can suspend those off the bottom of your truss cord and still move your curtain back and forth. As far as the fabrics go, the fabrics have changed dramatically over the last 30 years. Prior to that, there was some diversity, but not a lot. Most of the original fabrics were polyester, but with the advent of some really unique UV stabilized polyester materials, the fabric and the curtain material themselves have changed dramatically, and they allow you to do a lot of different things with the fabric itself inside the greenhouse. If you're looking to get more light but want to try and manage your humidity more effectively, then you can change what you're doing with the polyester materials. Some of them have open spaces between the fibers, and also between the way that the material is put together, and some of them are solid. So that solidness is usually a clear strip, and then there's an aluminized piece next to it. That's one of the types of fabrics that is out there. And then some of the other stuff is a solid black or dark gray material that's either lightweight or it's laminated with what they call a combined fabric. And it's a heavier material, but it does not allow any light in, and that's what's used significantly for light deprivation. The other thing that you'll see, and that's usually what the black white material is. Most of the material is the aluminized material. Most of what we're selling and we offer is the aluminized material for typical applications, and they're either in what's referred to as a fire retardant or a fire break. Originally, some of the materials that were out there were a problem with regards to fire, but the industry has really done a great job with coming back to offer those fire retardant items. And just about everybody that offers any product, for the most part here in the States, is providing a fire retardant fabric. Paul?
I think you covered that pretty good as far as the basics go. We're going to get into it a little bit deeper here in the next slide. But yeah, there's basically there's a different type of curtain system drive for different types of applications, different types of houses, which we'll talk about here in a second. And then there's the different types of fabrics for different types of applications, and the way in which you're cooling or shading your house. Okay, Tara, if you want to go to the next slide, we'll dive into this a little bit deeper. So this is a quick demonstration of a light deprivation greenhouse. So this is one where we're trying to control the photoperiod of the crop so it can flower. And what it's trying to demonstrate here is how dark these houses actually get. When you run these curtain systems, see it's a quick video, but when you run these curtain systems, um, you literally cannot see your hand in front of your face if you're blacking out the entire facility. That's how dark it is. If you're doing this during high noon in the summertime and you close that curtain system, you can't perceive your hand in front of you. Thank you, Tara.
Okay.
So going beyond the basics here. So the first thing I want to mention is going back to the different types of curtain systems that Scott was talking about. He said something that was pretty insightful. The flat slope curtain system allows for a bigger envelope, a bigger parcel of air underneath the curtain, which if anyone's been studying greenhouses for a long time and they've been studying why greenhouses keep getting taller and taller and taller over the generations, the idea behind that is you want a bigger parcel of air for more stability within the greenhouse. And the flat slope system allows for that, in addition to being able to hang stuff off of the bottom core of the truss, pieces of equipment, lighting, and fans, and things of that nature. Now, the other thing that's pretty cool here is both these curtain systems, whether it be a flat slope or a lay flat curtain system, you can add multiple curtain systems to them. So you could do up to 3 curtain systems in some cases with some of your high-end Venlo style greenhouses. Every time you add a curtain system, you nearly double the R value of the roof covering. So you're almost doubling the R value of your greenhouse. Most of the heat's lost to the roof, about 80% they say is lost to the roof. So simply adding one shade system, now of course you have to choose the right kind of fabric, one shade or heat curtain may help reduce your cost, let's just say, by 40% inside the greenhouse. Your energy cost, your heating cost. So it's going to obviously, like I said, depend on the type of fabric you're using. So some people are using fabrics strictly for shading and nothing but shading. Oftentimes they're using an open weave type of fabric, and it can vary from anywhere from 10% shade all the way up to high 70s. And of course, you can go blackout too. We got 100% shade, but most people kind of in the ornamental industry kind of target around the 40-50% level. Now then you also have the closed weave fabrics. Now the closed weave fabrics are going to be the ones that have the highest heat retention in most cases because it's not allowing any penetration of air between the fabric. So the upper layers of the greenhouse are not mixing with the lower layers of the greenhouse underneath the curtain. And those tend to have the highest heat capacity, heat savings capacity, but they may not be the best for your crop if you're worried about condensation and moisture. And I'll let Scott talk a little bit about that. Then you also have your aluminized fabrics, which tend to have an even higher, especially if they're closed weave, even higher heat retention capacity. And the reason being is what that aluminum does is actually captures the infrared heat that's trying to either enter the greenhouse or exit the greenhouse, and it more or less reflects it back down or holds it inside that space. So there's multiple things that we could do there for designing around the type of crop you're raising and what kind of need you have. Some people need shade. Some people need a combination of shade and energy retention. Some people are most focused on energy retention, just need a shade by a little bit. And then by using multiple layers of curtains, so we can have a shade on the bottom layer, we can have a heat curtain on the top layer, and then sometimes we can even add a third layer, and that'd be like, say, for example, a light abatement or a blackout curtain. So by using multiple curtain systems in conjunction with each other, you can make pretty much any condition you're looking for inside the greenhouse.
Can you tell by just looking at it what kind of fabric it is, for example, in this photo?
In this photo, this is most likely a polyester fabric. It's probably one around the 40-50% shade factor, and it's probably being used to diffuse light a little bit, if I had to guess. But this is most certainly a polyester only, and typically in this house here, you see it has an open roof vent. Typically, if we know we're going to have a passive greenhouse and we're in a warmer climate, we would try to target a open weave type of fabric versus a closed weave type of fabric.
Okay. This one is in Iowa, so it's cold in winter.
Okay, well, it does look like it has a twin wall roof though too, so it is getting some heat retention from that roof. But again, if you're focused solely on heat retention, you're probably going to look at more of a closed weave or aluminized type of fabric. And then if you're looking for more passive ventilation, most garden centers don't really have much going on in the dead of winter, right? So they may not be running this greenhouse year round. They may not need a high level of heat retention in the winter months for a garden center. Where a production facility, they probably would need that high level of heat retention.
I think the other thing that you're going to find too is that, to Paul's point about different people having different styles and densities on their fabric to control the light levels and control how much heat retention they want. If you can find the balance with your control, your environmental control, that allows you to really work that tool, that curtain, in a lot of different ways. And a lot of the enhancements in computer controls have gone hand in hand with the different fabrics that have come out, particularly with passive ventilation applications and being able to not only regulate the light, but to regulate the heat and to regulate the moisture and all of those different things that are all happening inside your greenhouse. So you can alter and vary that dramatically. And the growers look at things differently. Some growers want to have a 50 or 55% solar shade. They're able to regulate that. That's what works for them. And I have one grower in particular, and they use a heavy, almost blackout material on a regular basis, but they're able to use it, to Paul's point, on high-end energy savings because they have a radiant floor heating system, and the heat comes up from the floor, and they use that curtain to really save a lot on their energy, but they also use it during the high stress periods in the summertime for their crops. So they may only be shading with that gap that Paul was talking about before to help control the solar gain in the house and reduce the stress and heat buildup on that plant. With regard to fabric wear and tear, well, I'll go back to the condensation point. The fabric has a lot to do with being able to monitor and maintain your condensation levels, because it's helping to create convective air exchange in the house. You have a lot of air movement in the building. If you have mechanical ventilation, you have limited convective air exchange if you're passively moving air around. And now there's a lot of different enhancements with circular airflows and vertical airflows in order to move that air dramatically that the crop is going to require. And the type of curtain material that you have, the fabric within that shade, helps to monitor and maintain and control that. The fabric wear and tear is going to be it's going to be slightly different, but not dramatically different with the density on the material, but how it's put in and how it's suspended and the type of system that you have. The installation for the curtain means a lot. There's going to be different maintenance requirements on the system, and how that is established and designed will impact what's happening with your fabric wear and tear. The cable tensioning is part of that maintenance requirements on a spooling cable drum system. Motor failure, it can happen, but it's, since I've been doing this, it's very rare that I see motor failures on curtains. You may have some alignment problems with your drive lines that may create an issue, but for the most part, the motors last a good long period of time. And if you take care of them, whether it's a spooling cable or a rack and pinion system, they usually operate well. And the best way to prevent the issues is to have a regular maintenance program on the entire system. So at least once a year, you want to take a look at your drive lines, take a look at all your leading edge brackets, all your hardware, any problems that you may have had with storm damage to the external coverings on the house. Have they impacted or altered the curtain in any way? And if that's the case, then you want to make sure that you address that as well. Paul?
Yeah, so yeah, I agree with you 100% there, Scott. As far as fabric wear and tear, I think the one thing to keep in mind is whether you have a more of an open roof style greenhouse, whether it's an atrium roof vent or a full open roof vent, or even in some cases just a like a poly roof vent. Um, the wire spacing has a big impact on the amount of wear the fabric gets, how much billowing that fabric does when the roof is open. And also the choice of fabric has an impact on that too. Some fabrics are better stabilized at receiving that UV light from an uncovered roof, and so you can't just throw any random fabric you want into an open roof style house. Is what I'm getting at. You put a little bit more thought into the wire spacing that's holding the fabric in place, and making sure that it's not a fabric that's going to degrade readily under the UV. Cable tension, this is specifically related to the spool and cable system. Typically over time, these do tend to loosen a little bit and they require some maintenance, especially in the very starting bays, the end bay. But and that's not so much a case with the rack and pinion system, but you do have to get up there and grease the rack and pinions. So that's something to take into consideration, that you should make sure the rack and pinions are aligned, everything's sitting inside its casters properly for the push tubes, nice alignment there, and then always around the perimeter of the curtain system, you want to make sure that they're not getting snagged on anything, whether it be somebody putting a ladder up or just catching a piece of equipment. Like Scott said, motor failures usually not the case. You see some people try to drive too big of a system, and typically instead of having motor failure, you actually end up hitting a torque limit on the motor, and it turns itself off to try to protect the electronics and also protect the fabric. What I've seen most commonly is when somebody tries to drive a curtain system that's too big. More often than not, you see a shearing of the drive lines, and that's something we go in and we take care of for customers quite often when we see people trying to oversize their curtain system. And then as far as preventative issues, again, motors are very low maintenance. It's more about the rack and pinions and the cables that you want to be mindful of. Very rare do you have to actually do any maintenance to the motor itself.
How long, all things being equal and no storms, anything like that, just a normal life in the day of a shade curtain, how long do they live? How long do they last?
Great question. Many people take these curtain systems to 15 years or beyond. Okay. Now, that in an open roof style house, I think that's depending on how much you're using it, how often you're opening your roofs, and how often you're retracting the fabric. You might not get that full 15 years. Most fabric manufacturers recommend about 10 years per replacement, but the drive lines tend to last a very long time. So those will last generations, because it's mostly steel and aluminum. You may replace some of the wiring that's used, the wire bed. There's two different types of wire beds that are used primarily. There's stainless steel, which is the industry's, I think that's the gold star for the industry. And then there's monofilament, and the monofilament being a little bit less costly. But over time, especially with a open roof style house where you might have the leading edge kind of fluttering with wind blowing around the house, that monofilament will get abrasive and will require some replacement. So that may be replaced every time you do the fabric. But the fabrics, I've seen people take them every bit of 15 years in many cases. And sometimes you only get 10 years out of it if you're in a really harsh environment. Oftentimes they get dirty, and that's one of the reasons for replacement.
Yeah, it's the dirt and the dust more than anything else, than the fabric falling apart. So if you have a good way to clean it, it's not easy to do, but if you have a way that you can clean off the dust that's going to accumulate, then you don't have to replace the curtain as frequently. But I'm with Paul. I would say 7 to 10 years is the normal replacement on the fabric and the monofilaments. I have a lot of people here in the Northeast. They're able to go 2 curtain changes with the monofilaments. If it's stainless steel wires, they don't change the stainless steel wires. They leave them in unless there's a problem. And the drive line, usually you can get 18 to 25 years out of the drive line for the most part, something in there, depending upon how aggressive you are with opening and closing it. If you're moving the curtain a lot, then then there's going to be that much more wear and tear on everything.
Yeah, that's the biggest part, right, Scott? If you're using it all the time, then it's gonna wear out sooner.
Yep.
Is it hard to replace it? I mean, is above everything, is it major labor to get it replaced?
I wouldn't say it's easy. It's not necessarily hard, but you do usually have to clear the crop out, so you have to time it around the right time of the year, and you don't want to be up there when it's scorching hot and up in the roof of the greenhouse. So people typically plan these kind of maintenance and replacements in late fall. Okay. And then they'll start, because by the time spring rolls around, they're already stocked up, so they can't do it in the spring.
Yeah. Okay. How long does it take to? Well, I suppose it depends on the size, really.
Yeah. It depends on the size. One ribbon, one curtain, which is let's just say we're doing a truss to truss curtain system, could span multiple houses, and you kind of weave it in between the fabric or between the wires that are the lower bed and the upper bed. So it's not usually that hard. You usually got somebody that's on a lift if you have a nice clear floor space, and you have someone that's kind of feeding it so it doesn't snag as they feed it up. And then there's just a person on a lift going down the length of the house or down the from column to column.
Okay.
To Paul's point, Tara, really what you find is that if there's nothing in the greenhouse and they have direct access both horizontally around the floor of the greenhouse and vertically, there's not a lot of conflict. They can work pretty quickly, but when you have to change out parts and pieces, depending upon how heavy and conflicts with other items that are in their utility lines, equipment, that's where it can be more troublesome. Most of the time when the greenhouse building is built, the curtain is usually the second thing that starts to go in. A lot of the stuff that's done overhead, the curtain is usually the second or third thing that's going in once, depending upon whether it's horrible weather and they want to try and get covered, or they want the house to breathe a little bit. They'll go ahead and put all the mechanicals in to move those systems, all the drives line and all that other parts of it.
And this is where grower preference really starts to show difference here. On a smaller range, a flat slope, push-pull system, that's maybe a little bit more of a premium than a cable system, but it's going to install very easy. It's going to be replaceable very easy. Then you may have a cable system, which on a large scale, the capital cost is going to be less than a flat slope system, but think about the maintenance, because oftentimes this fabric's hooked into a wire, and now you got to pull this fabric and reclip each hook as you go to replace the fabric. So there's advantages and disadvantages to both systems. Some have lower capital cost. The cable system tends to have lower capital costs up front, but I would say the labor and the replacement is a little bit higher over time.
Okay. And that brings up the question of what is the cost of, roughly?
Well, the cost is going to vary depending on scale. That's the biggest factor there, because one motor can drive your single bay garden center, which may be 30 by 96, or if you look at these large motor systems that we use for, in the produce market, one motor can drive maybe up to half an acre. So, and it depends too on the type of system. So that's a pretty loaded question, unfortunately. But I'll say this: when you're looking at marginal rate of return for your pieces of equipment that you're buying, so you could, if you're a grower and you have a pool of money at the end of the year, and you're like, I can invest in any number of things in my greenhouse, one of the things that's going to give you the best rate of returns is going to be your curtains and your benches. Anything that improves your heat system or your labor have some of the higher rates of return.
Okay.
Again, in a perfect world, a curtain system almost doubles the R value of the roof. So that's like spending half the fuel you'd be spending on your roof on your heating if you have a large greenhouse that has it's almost all roof and very little sidewall.
Okay.
Scott, do you want to take this?
I'll let you go ahead. I'll jump in.
Okay.
You can take the first one.
So the first one's a little bit of a tough one. What's the right percent to leave the curtain open for airflow without losing heat? Well, this one I don't know if there's a standard across all the U.S., but I will say that there is a smart way to use your curtain system in the winter months when opening them up in the early morning hours. So the one thing that more so about losing heat is about mixing. One thing that takes place with a curtain system when you open it up in the morning hours and you've had all night that cold stratified air up in the attic space above the curtain. It's right up against the glazing, so it's losing heat through conduction pretty quick. What ends up happening is when you open up your curtains in the morning hours, um, that cold air drops, just like your weather pattern would have. The cold air drops and it mixes in with the lower with the greenhouse air down at the lower levels, and it causes a lot of cycling of your equipment. So your heat turns on and off relatively fast, back and forth, trying to fight all that immediate change to the greenhouse environment. So what growers tend to do is they tend to crack it slowly and open those curtains slowly over the course of the morning. So they're getting more mixing of that cold air up above with the warm air down below, and then they kind of mix up in the attic space too. It helps minimize condensation while simultaneously not putting a massive strain or massive load on your heating system and dropping the temperature down at the crop level where you really care.
The other thing too is to Paul's point there. You want to have the curtain seal as well as it possibly can, and some of the systems that are out there have what they call a leading edge bracket, and that bracket moves to seal inside a closure, and then some of the other ones just have a forward leading edge and a small little neoprene or rubber flap that moves again up next to that truss in order to try and create that seal. But the reason for that is the temperature changes between the bottom of that curtain and the top of that curtain, and then all the way up to the glazing system, can be dramatic. And with a winter like we had this year, and when you have degree days like we've had this year, you'll have ice, on the inside of a lot of the glazing materials, and it's cold. And that, to Paul's point, that curtain opens just a tiny little bit. You want that air to come down and mix slowly with the greenhouse air that's accumulated itself at the top top of the closed attic space, which is the bottom of the curtain, and allow it to mix. Otherwise, if you open it up too quickly, that cold air, it crashes, and it not only stresses your system, but it'll damage your plants. It'll harm your plants for sure. Yep.
So one of the things Scott was bringing up was about that seal, and so for an ornamental grower, wholesale grower, chances are they're not adding supplemental light at the finishing stages of the crop. So on a cold day, on a very, very cold, overcast day, a lot of times these growers will just keep their curtain closed. They know they're not going to get any growth benefit out of that day because just the amount of light that's coming into the greenhouse. It's just too cloudy. This picture is actually a pretty good example. It's just kind of overcast, not a whole lot of sunlight's coming in. They're not getting a whole lot of growth, so they'll make the determination just to keep the curtain closed and try to maintain heat as much as possible. And that's where that seal that Scott was talking about really makes a difference. Just minimizing the amount of convection that takes place between above and below the curtain. And I think we might have touched a little bit on this humidity question, but again, so there's multiple ways you could do this to maintain humidity and prevent drips or minimize the number of drips at nighttime. Again, we talked about was an air exchange between above and below, and they make fans that do that too. That exchange air between the upper layers and the lower layers. Um, but then there's also a methodology which we see quite often, and sometimes people call it the poor man's roof vent, or sometimes they just call it what it is, an upper gable shutter and exhaust fan. So one of the benefits about bringing in outdoor air and then reheating that outdoor air in a curtain system that's closed at nighttime is that outdoor air, if it's cold, it's going to be very low humidity, especially if it warms up by 10, 15, 20 degrees in that attic space of the greenhouse. It's going to drop its humidity really quickly. And that will help reduce the amount of condensation that takes place on the glazing system. So what you'll see some people do in a curtain system, oftentimes these are non-permeable curtain systems, so they're closed weave. They're not letting a whole lot of condensation or a whole lot of humidity move between the lower levels of the greenhouse and the upper levels of the greenhouse. Is they'll turn on an exhaust fan up in the peak of the greenhouse at nighttime, just a small shutter and fan to kind of move out that humid air and replace it with dry air. And then, of course, once it warms up in that attic space, they won't turn on a whole lot. They'll just kind of pulse it. Once it warms up, just through conduction through the fabric, um, they end up getting the attic benefit out of it, the insulation benefit out of the curtain system again.
Yep. As far as the savings, realistically, well, again, it depends on the fabric. The fabric is really going to determine that. And I would say that if you're going to put a curtain in of any kind and spend the money for it, that you should look for at least a minimum. I don't know how Paul feels, of 20 to 25% of heat savings, and you can ratchet that up and move that up again depending upon how heavy your cloth is. The heavier the cloth, the fabric that's in there, the better heat retention you're going to get from it for sure. And as far as if one layer is enough, again, you got to take a look at what you're growing and how often are you in there, how much control do you need, and what can you afford? I mean, what's your budget? I mean, if you have plenty of dollars, then the crop is going to yield significant dollars over time. Then having an additional curtain is a good way to go. As far as curtain drive failures, no, like I said earlier, I really haven't seen it. It's just a lack of maintenance more than anything else. Is what I would say. Paul commented on that. And then as far as strategies for different differences between glass and poly, I think that you're going to get more light for sure in your glass greenhouses, significantly more light, 20% or more over poly, and the same with polycarbonate. So you have to manage that light effectively, and how you put in your curtain system is going to reflect, controlling the amount of light. It's all about getting more light. More light is going to give you better productivity and more yields with your crop, is what I would say. Paul?
I agree with that. I do want to mention that some fabrics these days have different light transmission, whether your glazing system be diffused or clear. So with glass, I mean, it comes in two different flavors, right? You can get diffused or you get clear glass, and the amount of light transmission through the shade fabric, or the amount of shading that the shade fabric's doing, varies depending on which type of glass you have. That all goes into consideration when we design curtain systems and we size or spec out the type of fabric that we're using in them.
As far as the differences in the systems, I don't really think that there's going to be any differences between the systems. I think that they're going to be the same. I think it's the fabric that you would be using more than anything
I agree.
else.
I would agree. Yeah, the type of fabric. The other thing I would say is maybe in a more northern climate, you might see more than one curtain system. You
Right.
know, when our produce projects up in Ontario tend to have two or three curtain systems. When you get down to places like Florida, you'll never see a double curtain system down there unless they have a reason for light abatement.
Right.
Okay.
Okay, we
Go
kind
for
of
it, Paul.
talked a little. Yeah, we kind of talked a little bit about these already. The troubleshooting, at least. What can go wrong with the fabric system or with the curtain system. Typically, again, they're kind of set and forget it, and you do the maintenance on them once or twice a year, and just kind of make sure you're conscious about it when you hear it running, that you don't hear things buckling or getting stuck or large pops sometimes. But again, troubleshooting, it's more about maintenance than anything. Of
Yep.
course, once your fabric starts to degrade, it becomes more problematic. That's the one thing I'll say. Once your fabric starts to strip or get holes in it, it's just a matter of time before a thread of it gets caught on something. And then once you have it caught on something, you can have even more damage than
Yeah,
just
then you get
replacing a fabric.
yeah, if it starts to shred and you don't replace it, or at least take that piece out at the very minimum,
Hmm.
then you could end up, having a piece of that fabric snagging or hooking on something else, and you could end up with a catastrophic failure. And that's what you don't want. You want to make sure that you can have a safe environment for your people and your plants, and then make sure that if there's an issue, that you address it right away. But there's nothing worse than having a cut piece of fabric that's failed and is time to be taken out, that's just
Yeah.
ignored. And then you get a windy day and you start to get some flagging, inside with the curtain, and then it starts wrapping around stuff. Then you got a problem for sure.
Yeah, in particular, a real nightmare when it hits say your garden center with fire sprinkler heads, and it gets snagged on one of them heads. Now you've trashed everything underneath the
Yeah.
sprinkler system you had to go off.
Dramatic.
Yeah.
The other thing I would say with regard to challenges, Paul kind of touched on it earlier. I think that the light abatement thing is going to become a bigger issue as there's more suburban sprawl and more things going on in and around where growers have been for years. There's going to be more pressure from people that are living in the area, that they see there's a glow over on the far western side and the sun has set a long time ago. They want to try and people are putting on artificial lighting in their greenhouses. They want to make sure that they're aware of that, and they need to budget and consider that accordingly for sure.
Yes, we're building more and more up in urban wildlife interface areas. Up in Montana and Wyoming and Idaho and Washington, eastern Washington, and there's elk migration, and things of that nature. They're all, people are concerned about what the light impact is on the environment, so they're mandating that these greenhouses have light abatement. We're also building them not too far from airports, and that's another thing I see too. We just built one up in Boise that was not too far from an airport, and completely light abated the ceiling. Of course, the walls we didn't do anything on, but just the roof of the greenhouse. So that's become more commonplace.
And certainly with the cannabis facilities, more than anything else, they're already going to have them. They're going to need to use that for that. Yep.
Correct.
We do have a question. Oh, sorry. We do have a question. Besides holes, tears, etc., are there any other signs of curtain fabric degradation? So can you see it's about to give way? If there aren't holes, does it look a little ragged? I mean, how can you tell?
Well, I'll speak to that, Paul, initially, and then you can jump in. The wear and tear is going to take place along any connection points to the fabric. So that will be where it's trapped and secured on the stationary edge, on the front side where the system moves and the leading edge goes from point A across the travel distance to point B, and then how it's sandwiched and put between the wires or the monofilaments along those lines, on each of those lines. That's where the first wear and tear will be. You'll see that. Or where there may be hooks in a suspended system or around the perimeter. Those are going to be the locations where there's any stress points on the fabric as it lays on its bed.
That's exactly what I would say, Scott. It's more often than not, it's where it's attached or where it's touching and rubbing, abrasing against something, and almost all these curtain systems rest on a wire bed. So oftentimes I could tell if a curtain system is about ready for replacement, even if it doesn't show tears yet. It looks like it's thinning along that wire bed, so you can almost see through it in places, even though it's still technically intact. It's just a matter of time before it breaks.
The other thing too, Tara, is as it loses, as the fabric loses its elasticity, it becomes more and more brittle, like any other plastic. And in some instances where there is that wear and tear, it'll start to dandruff out. It'll start to fall apart and rain small pieces of the curtain itself down and inside the greenhouse.
Okay.
But that's old stuff. That's really old stuff. That's,
Yeah.
That's stuff that really needs to be replaced because it's going to impact your crop and impact what you're doing underneath. Yeah.
Yeah. Another question: how does curtain use change for vegetative versus generative steering?
That's a good question. Well, I'll say most people when they're doing steering like that, they have more than one curtain system. You may have heard the Par Perfect system, where they would use two curtains and counterflow with each other to deliver the ideal light levels, ideal temperatures inside the greenhouse, and that's typically how that would be optimized. It'd be part of the control program. So you'd say, okay, I have a crop at this stage inside my greenhouse, and I'm trying to maintain these ideal parameters. And the controller, a lot of the times these controllers nowadays are even machine learning or AI, or they're moving in that direction at least. They would adjust based off of that. The other thing that we're going to talk about, if you want to flip to the next slide, is what's kind of in the future with these same control systems. We're starting to see more predictive weather capabilities, so they may preemptively tell the curtain some kind of something to some outcome for the curtain system based on an algorithm and ground source meteorological stations that it's drawing information from nearby, saying, okay, it's going to be a cold day. 50 miles to the west is overcast and cloudy. We're not going to even bother opening up the curtains this morning. We're going to just try to maintain temperature so we can optimize our energy use in this greenhouse. Or they could say, hey, it's getting relatively hot really quick. West of us, we're going to preemptively cover the curtain, cover the crop, in order to maintain temperature in the house and not let it overheat today. So you'll see it in that kind of in those kind of ways.
To Paul's point, I think it's a combination of all of the above and building the proper structure to allow you to do all these different things with the curtain. If you need to put two systems in or three systems in, and does one work one way and the other work the other way, and how can I monitor and manage all of that light that's coming in, and also control the temperature and the mixture of the air within the greenhouse to enhance my productivity and have a better crop. And is it cost justifiable to do all those things with those tools? That's really what it comes down to. It's that balance for sure.
That's a good segue into the next question, which is, what role do horizontal airflow fans play when curtains are closed? What role do HAF fans play when curtains are closed? That's mixing the air, correct?
Mm-hmm.
Primarily, yes. So, I mean, the horizontal airflow fans are I think, first and foremost used for heat mixing. but they also help a lot with managing the VPD within the greenhouse, to be able to kind of make it more of a uniform humidity level and air temperature at the leaf level in the greenhouses. Um, so again, it's just another tool in your toolbox. I don't necessarily think that, I'll let Scott chime in on this. I don't know if the strategy changes a whole lot when you go from having a closed closed curtain system to an open curtain system in the greenhouse. I'm not too sure about that one, actually.
Well, I would think that it makes a difference because your envelope has changed. So now you reduced all, if the curtain's closed, you've reduced all of that attic space, the impact that attic space is going to have on the balance below. But to Paul's point, my feeling with the HAFs is that they're designed to move the air within that zone constantly, and they are also used primarily as booster fans, particularly if you have unit heaters inside the greenhouse. They help you to regulate and manage that air more effectively. If the curtain's closed, then it's going to be a smaller envelope, so they are going to impact it. How much more they're going to impact it, I would think that it would be increased. It'll impact it more if the curtain's closed because there's not as much area for them to mix, and there's not as much air to mix, and you're able to regulate and control the differences between the two temperatures above the curtain and below the curtain, both in the summertime for shade and in the wintertime for heat.
Touching on that summertime topic, Scott, what you said made me think of something. I do know that in cases where customers have the HF fans pitched downward slightly, this is more of the case for a mechanical house versus a passive ventilated house, but they have their fans pitched downward. Oftentimes, if the curtains pulled back, retracted, and the attic space is quite hot, I see those HAF fans bringing that heat out of the attic space back down to the crop level, which is an undesirable thing to do in the summertime, right? So I've seen people do that before on accident, not knowing they were doing it, just having those fans too pitched downward toward the crop. Some people try to use those fans for things outside from what they're intended to do. Typically, like I said, they're intended for uniform heat distribution, uniform moisture distribution in the house, so that all your crops, so your plants grow at the same rate, have the same climate.
Yeah, but opening the curtain a little bit is going to allow for that stratification that's going to take place, to allow that warm air that's going to build up to move up and into the attic in a passively ventilated building. In a mechanically ventilated, then it's a whole different animal. Yeah. And usually if it's a mechanically ventilated house with the curtain closed or not, that if you're in full cooling, a lot of times your HAFs aren't even running anymore. They shut down.
Yes.
And you're in full exhaust flow and exchanging that air from one end to the other, within a minute or sometimes less. Yep.
Okay. All right. Well, thank you. We're perfectly timed. 2 minutes before the end of the hour. Brilliant. If anyone has any questions that weren't answered during the course of this webinar, those are the emails that you need to use. Scott and Paul put their work emails, and then the general info email box, I monitor that and distribute it to wherever it needs to go. So thank you very much for your time. That was very informative. I enjoyed it and learned quite a lot. And thanks, Scott and Paul. Thanks for your time.
You're very welcome. Thank you. We appreciate you putting it together and letting us share the wealth.
Good.
Thanks for tuning in, and know that our website, our Prospient website, has a great wealth of knowledge in terms of white papers and other information on the subjects.
Yes, and hopefully next month we are working to get a more in-depth curtain system look at a produce facility. So if you're interested in that, keep an eye on our channel. You'll get the emails as well. So we're working on it. We haven't set it up yet, but we're trying.
Sounds great. Thank you.
Thanks very
Thank you,
much,
everyone.
everyone.
Have a great day, everybody.
Bye.
Bye-bye.